Hi guys, thank you for joining me to a new class. Today guys, as you may know, we're going to be working with division. We have already added, subtracted, multiplied, and then we're going to see how to divide polynomials. But before going into that specific topic, I want to review something and I want to show you guys to recap, or I want you to recall some properties that we're going to use when dividing polynomials. First of all, what is this? Let's suppose, guys, this is a properties. The pink ones are properties. Let's suppose that you have a variable raised to a certain power m, and then you have over the same base, the same variable raised to another power. So what do you think is going to happen, guys? If you have the same base divided, what do? We copy the base. I'm going to give you an idea, but what do we do with the little numbers called exponents? X and X is the same base when they're dividing. So we copy the base. And what do you think I do with the exponent, guys?
We copy.
When multiplying, when the variables are multiplying, we copy the base and we add the exponent. So when multiplying, when dividing, what do you think is going to happen with the exponents? We copy the base and
we subtract.
We subtract the exponent, right? Yes. That is the property. Minus. Okay, we copy the base. If they're dividing, guys, we copy the base. If we have the same base, we copy the base and then we subtract the exponent of the numerator minus exponent of the denominator, just like that. So let's have a look at this. An example, pretty easy. X raised to the 10th power over or divided by x cubed. So you said, Mr. I have the same base. So this is repeated. So I don't need to have the same variable repeated. So I'm going to simplify. What? Okay, I'm going to copy the base, x, copy the base. And I'm going to subtract the exponents, 10 minus 3. So you can do it at once, guys. You can copy 10 minus 3 and then simplify. But if you can do it mentally, it's even easier. 10 minus 3?
7.
7. Correct. 7. X to the 7th power. And that is how do you simplify this, guys. And now, let's have a look at another property. So if you have whatever variable, whatever expression raised to the 0 power, what is that equals to? Any number, any expression raised to the 0 power is?
0.
It's close. It's 1. Okay, why? I'm going to explain to you why. But whatever you see, guys, raised to the 0 power, that's going to be 1. No problem if you don't remember this property yet. So let's have a look at something here. Okay, let's suppose that we have this. So now we have a raised to the 3rd power and then a raised to the 3rd power. Okay. So what are we gonna do here, guys? We have the same base, right? A. What do I do with the bases?
Subtract.
I copy the base and subtract the little numbers exponent, right? 3 and 3. Okay, let's subtract. What is 3 minus 3, guys?
0.
0. Okay, that is the answer. But that, guys, raised to the 0 power, it doesn't make sense. What is a raised to the 0 power?
A to the first power.
1.
A to the 0 power will be just a 1, correct? That will be the 1, thank you, okay? That means 1. Whatever expression raised to the 0 power is 1. Okay, and some books suggest this, guys. If you have the same a raised to the 3rd power divided by a to the 3rd power, this makes sense, guys. Something divided by the same thing, what is that equals to, guys? 3 divided by 3, for example. 4 divided by 4? 1, right? If you have 5 divided by 5, that is 1. That is exactly what's happening here, guys. A cubed divided by a cubed, that is the same quantity. That is equals to 1, right? But we're using the property. So any question, guys, on how to use this property? If we have the same base divided, we copy the base, we subtract. Whatever expression raised to the 0 power, that is equals to 1. Let's have a look, closer look, guys, at these expressions. So now let's suppose that we have a negative exponent. So guys, whenever you see a negative exponent, you have to work. You have to deal with that because that's not okay. So and how do we do that? So the property, guys, when you have a negative exponent is really easy. What are you gonna do, guys? You are going to move this expression to the denominator, and then it's gonna be positive. What is that? Okay, I'm gonna do that. I'm gonna move exactly this x raised to the m power. Okay, x raised to the m power, but now it's positive. That's how I get rid of the negative. I move that to the denominator and now it's positive. But I copied exactly x raised to the m power. Instead of negative, now it's positive. I just move this to that denominator. So, and now what I'm gonna put here, guys, I'm gonna leave it like that on blank. What number do you think I'm gonna need there?
The same.
If I don't have it, guys, it's gonna be like the imaginary number, okay? 1 divided by this one. If you have a number previous to this one, you're gonna put the number, but in this case, since I don't have it, okay, it's like I have a 1 here. That's why I put a 1 in the numerator over this. I just move this to the denominator. And that's how I fix that. Let's have a look at some examples. So let's suppose that you have x raised to the -3. Oh, you said, no, 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 this is not okay. So how do I fix that? Say, what are you gonna do, guys? You're gonna say, okay, this you -3, since you are a negative, I'm gonna put you in the denominator, and then you're gonna be positive. X cubed, now positive, take a look. I just moved to the denominator, positive. And since I don't have any number here, what number do you think I'm gonna need here to complete fractions? 1, correct, it's 1. 1 over 3x cubed, that is the answer. Correct. Let's have a look at another example. 4x to the -6. Okay, again, the same. You said, oh, something is wrong here. I can't leave this negative. Okay, x raised to the -6. Okay, this x raised to the -6 power is pissing me off because it's negative. I'm gonna put it on the denominator. And what number? I need a number here, guys. I cannot leave it like that in blank. Oh, but mister, in this case, I have a number. It's 4. Okay, you don't need that 1 anymore because you have the 4 already. Okay, you put the 4 because you have it here. Okay, 4 over x to the 6th power. And this is how we deal, guys, with negative powers. Okay, negative powers. Let's have another look here. We have more examples, guys, to get rid of any doubt. Okay, we have 4f raised to the -1 power. Notice something here, guys. That in this case, 4, I didn't put 4 down because 4, guys, is positive. And the only one negative here is the -6, the x. However, here, guys, the parenthesis is telling me that 4 is raised to the -1 power as well as f is raised to the -1 power. Okay, all of what it is inside of the parenthesis is raised to the -1 power. So how do I do that? Okay, all of these, guys, again, is -1, right? I'm gonna move them down for f, okay? And now it's gonna be raised to the first power, right? Positive, because I moved it down. So, but guys, if it is 1, you don't need to put 1, guys. You can leave it just like that because it's not necessary. We know it's a 1. And what number should I put on the numerator, guys? Because I need something here. I can leave it like that.
That way.
In this case, I'm gonna put the 1, right? Again, because I don't have any other number outside. Okay, 1 over 4f. Okay, if you don't have number out of the -1, you put 1. Let's have a look at this one. 2a is another example. 2a is another example. Okay, now let's see 2a, and we're gonna do the same thing. Okay, 2a is raised to the -7 power. So what am I gonna do, guys? Again, I'm gonna cover this, and I'm gonna move that to the denominator. Okay, 2a raised to the what now, guys? +7, right? +7th power. And I need something here, guys. What number I'm gonna use?
1.
It's 1. If you don't have it, just fill it with a 1. And these are the properties, guys, that I wanted to review with you, because we're gonna need them when dividing polynomials. Let's recap. If they're dividing the same base, you copy the base and you subtract the exponent. Whatever expression raised to the 0 power is equals to 1. If you have a negative exponent, you move that to that denominator. Okay, that's pretty much it. So since we have already reviewed the main properties we're going to need, let's get down to work. We're going to divide polynomials. So we have two cases when it comes to dividing polynomials. A is dividing a polynomial by a monomial. Monomial is an expression, a single expression, okay? You have something big, like this case. This is a binomial, a polynomial, and then you divide by a monomial. So 3x's are just a monomial. So, and that is the first case. And the second case is going to be dividing a polynomial by another polynomial. Something big divided by another expression that is as well as, or I mean big. So polynomial by a polynomial. But let's see what we're gonna do. How does this work? Okay, let's zoom in just a little. Let's suppose we have 6x squared minus 15x, and all of that is divided by 3x. So how do we tackle this? So straightforward. So what we're gonna do here, guys, take a look. This and this, guys, all of this is over this. This 3x is dividing this. So what are you gonna do in this case, guys? It's very simple. You are
We
going to
simplify
separate.
this.
Tell me.
We can simplify this.
Yeah, that's what we're gonna do. Simplifying, actually. It's not like a big division. It's like, we can think about this like a simplification or simplifying this. 6x and 15x is divided by 3x. What I'm gonna do, I'm gonna split this 3x, guys, for the 6 and into the 15. What is that? So let me copy that again, okay? It's gonna be equals to, I'm gonna copy 6x squared, okay, minus 15x. And then this 3x, guys, is dividing 6x squared as well as 15x, okay? I'm going to separate this 3x, okay? 3x dividing here. And then 3x dividing here. It's the same, right? It's exactly the same thing. I just
Yeah.
separate this and this. And now, what I'm gonna do? So let's divide 6 divided by 3. What is that equals to, guys? 6 divided by 3?
2x.
Is equal
2, correct, 2. And now, x squared divided by another x. Okay, this is the first power, mister. Okay, we have the same base, guys. Okay, we copy the base. And then we subtract 2 minus 1.
1.
1, okay? If you don't want to put a 1, that's okay. Okay, minus, let's continue. 15 divided by 3.
5, 6. 5.
5, correct. 5. And then x divided by x.
X.
Okay, let's do it here. X divided by x, okay. We copy the base, okay, and we subtract the exponent. The exponents here are 1. 1 minus 1?
1. 0.
0.
And is
X raised to the 0
1.
power?
1.
It's 1, right? It's like, okay, if you don't want to follow all of this process, you say if you have something equal and something equal, you cancel that, and that is equals to 1. That is what is going to happen here. We can cancel this. We can cancel this because they're the same, and you have 1. But 5 multiplying 1, guys, is the same 5. Okay, I don't need to put it. Okay, I cancel the x's. In case you don't have any other expression, you put 1. Just 1. And that is the answer, guys. Really easy, right? Let's have a look at another example. Let's go look at example number 2. Okay, again, a polynomial divided by a monomial. So again, in this case, guys, this symbol is division. Okay, I know this is divided this. Okay, what I'm gonna do, guys, I'm going to separate this again because I know this is dividing, right? In this case, the difference is that we have the division symbol. Okay, this is going to be dividing this. This is going to be dividing the 18, and this is going to be dividing this. Okay, I'm going to copy this again. Okay, once I copy this expression, okay, I know this is going to be divided in this. Okay, I'm going to separate the denominator because this is like the denominator, correct? Okay, that is going to be divided, guys. This expression is going to be divided in this. Okay, 6ab over 6ab. It's a divisor, right? 6ab. Okay, I just separated the denominator. Okay, now it's time to simplify. Let's simplify. Let's see what we're gonna get when simplifying this. Again, just one at a time. 24 divided by 6. Someone help me with this. 24 divided by 6. 4, right? 6 times 4 is 24. 24 divided by 6 is 4. Now let's go to the variables. A raised to the fourth power and A raised to the first power. So we copy the base A. Okay, we copy the base A. And then we subtract 4a minus 1a. 4 minus 1.
3.
3 cubed, correct. Let's go to the b. V cubed divided by v. Okay, we copy v. And let's simplify it again. 3 minus 1.
2.
2, which is square. Correct. And I just simplify the first term. Now let's go to the second one. Plus is positive. We just get the positive sign down. And now 18 divided by 6. 18 divided by 6. I think it is 3. Okay, now a raised to the second power divided by h raised to the first power. We copy a, copy the base, and we subtract. 2 minus 1. It's 1, correct?
1.
Then, correct. Let's go to b. B squared
1.
divided by v1. 2 minus 1 is v1, correct? Finally, minus, okay, it's minus, I get it down. 30 divided by 6.
5.
5, correct? And then a divided by a. If you have something, guys, equal, divided the same quantities, guys, it's like you can cancel then. It is a property, but you can skip that step. That is 1 because it's the same. And I only get b3 divided by b1.
B2.
B squared, correct? 3 minus 1 is 2. This part, guys, I just cancel because it's like you have a number here. 6 divided by 6 is 1. You cancel, but I don't need to put 1 here, so it's okay. This is the answer, guys. This is how do we divide a polynomial by a monomial. All right, let's have a look at another expression. Trinomial divided by a, or I don't know if this is division. Mister, this is a multiplication, right? This parenthesis multiplying this expression. Yes. And can you see something weird here, guys, in this expression?
There is a point in the middle.
A point, which is multiplication, but this is not division. Then, what else do you see different, guys?
The negative 1.
Oh, right. Yes, there is a negative 1, guys. In this expression, that is not okay, guys. How do we get rid of negative 1 expressions?
We pass that expression to the denominator.
Correct, Mauricio. This is exactly what we have to do. We need to move this expression to the denominator. Okay, let's copy the numerator. Okay, let's copy the numerator. Let me copy this. I'm going to copy exactly what I have. 33 x squared y6 power minus 60 x y to the fourth power minus 15 x cubed y cubed. And okay, if you want to use parentheses, that's okay. And this expression, because it's negative 1, is raised to the negative power. I'm going to put then to the denominator, correct? All right, that's what we learned in the property. Okay, I get rid of the negative by putting them down. Okay, I'm gonna put it down so you can put negative 3 xy squared. And now, guys, raised to the first power. Okay, you don't need to put this one. Raised to the first power. And now it's a division, right? Take a look that it looked like multiplication, but we convert it into the division, okay? Because this is -1, I move it down. Okay, now what I have to do, guys, this is divided by this. Okay, I need to separate, right? I need to separate this. I'm gonna copy again, 33 x squared, y 6th power minus 60, x y to the 4th power minus 15, x cubed y squared. And then I'm gonna separate the denominator, guys. -3x, I don't need the parentheses anymore. -3x y squared over -3x y squared over -3x, okay, x y squared. And let's see what we're gonna get out of this. Can someone give me a hand, guys? How do we simplify this? Okay, again, one at a time. 33 divided by -3, guys. Positive and negative. Of course, I'm gonna get negative. Negative what? 33 divided by 3? 11, right?
No, yes.
11. Okay, now let's go to the variables. x2 and x1. Let's subtract. 2 minus 1? 1, right?
1.
2 minus 1 is 1. Now with the y's. y6 minus y2. Y
Is y to the first power.
raised to the 4th power, correct. Minus, let's move on again. 60 divided by 3. Negative and negative. It's positive. 60 divided by 3, guys.
20.
20. Now, x and x, mister. I have the same quantity. I don't even need to use the property. It's like I can cancel them because they're the same. It's 1. There's a 1 there. I don't need a 1. And then y4 divided by y2. y4 minus y squared, correct. y2, okay. And minus again, minus and minus is going to be positive. It's going to be positive. And this one, 15 divided by 3, 5, right?
5.
5, correct. And then the x3 and x1, we subtract x squared. And then y2 minus y1.
Is 1.
y2 minus y2, sorry. We can cancel them. They're the same. It's just 1. And this is the answer, guys. This is how we divide polynomials by a monomial.